Okay, good morning, everyone, and thanks for joining our webinar today, which is titled Beyond Vessel Tracking, Maritime Intelligence on Your Data, Your Infrastructure at Any Scale. My name is Bart. I'm one of the co-founders of XYZT.ai, and I'm also one of the technical people within the company. So thank you for joining. We have a very diverse audience, so we'll make it a little bit interactive, and I will steer the demonstrations and the demos in the direction that you like. And we will do that through a poll. So I will ask you to participate and give your preference of the type of demos that I should give. I prepared a lot. Unfortunately, I cannot show everything today. You can ask questions, but please put them in the Q&A, and we will tackle them at the end of the webinar so we can take all the questions then. So with that, let's get started. Since we're all in the maritime domain, we do know that there are quite a few challenges. We've seen a lot of congestion as a result of certain incidents. And of course, also we've seen the impact of the geopolitical situation in Iran. And all those incidents or events that are happening in the maritime domain, they ripple through the entire economy, through the entire logistics chain. And as a result, I think maritime has seen a lot of attention in the news over the last months and years. And people have seen maritime vessel tracking in action a lot, like mostly through marine traffic. People have seen how vessels are being tracked and traced, and there's a lot of awareness around this. And those websites, those tracking apps, they've seen a lot of increase in visitors. And people start to understand that increasingly more that the data is there and also maybe what can be done with the data. And so today I want to show you how over the past 5 years, XYZT.ai has been helping our customers to move beyond vessel tracking, to move beyond seeing where vessels are now, but to really go into what we call maritime intelligence, to understand what vessel activity actually means. What's the impact of certain things? How has maritime activity been changing? And so on and so forth. Before going into that, I will talk a little bit about XYZT.ai. So our name comes from XYZ location T time. We are an easy no-code platform for maritime analytics. And it's a space-time analytics platform. So you see on the screenshots, you see a map, you see a timeline, you see layer controls and so on. And the screenshot that you see is actually from our very first customer. Our very first customer was and still is Spire Maritime. Nowadays, they're part of Kepler. They've been acquired. And at the time, Mark Deverill was running the operations, the data quality assurance. And he said it was just incredible seeing their data for the first time at a global scale. We try to make it easy for people that are not used to work with data, that are not used to work with Python or with coding. So we want to make it as easy as a BI platform. And our goal is really to help you turn maritime data into actionable insights by giving spatial and temporal insights, by working not only on smaller data sets, but also scaling to billions and billions of location records. And very importantly, by allowing you to connect your own data. So we are not coming with data inside. It's really with an API, we drag and drop, you can upload or connect your own data. And we are in the market really to work with partners. So we typically don't go direct to the end user. We really work with integrators, with data companies, with technology companies that integrate us in their go-to-market strategy. And the goal is, of course, to accelerate your business, to accelerate your business model. I'm going to give you a few screenshots of some of the views, some of the capabilities, and then later on I will present a number of use cases. But I will let you select the use cases that I will demonstrate because I prepared, I think, 7 use cases with 15 demos, and it proved to be a little bit too much to tackle in half an hour. So we do space-time analytics on big data. You can do it also on small data. You can do it on aggregates of the data. You can do it on individual movements or traces of vessel movements. So that is all supported, and we have our own technology to handle these big data sets. You can do replay very accurately if you have the dimensions of the vessel and accurate positions. You can do replay and incident analysis. You can combine multiple layers. Here is an example with ECDIS charts. They can come from, for instance, from OGC WMS. You can do before-after analysis. We support also gridded data, where you can combine, for instance, historical ocean data together with vessel tracking data. It's not just about points, it's not just about locations. We also support time series data. So, for instance, if you already process vessel tracking data into more aggregate data, for instance, counting the number of vessels in terminals in your port or in anchored zones over time, you can visualize and analyze this data as well in the platform. The platform goes beyond maps. It goes all the way towards statistics, towards trends, towards origin destination and dwell times. And you can do that on real-time data and historical data. Increasingly also, and this is a bit surprising to us, we get increasingly more requests for handling data outside of the maritime domain. For instance, imagine you're on a vessel and you want to understand how the past aviation picture looked like, or maybe how the real-time drone situation is in your neighborhood. You can also connect this type of data to our platform. And then finally, the platform is not only used by analysts or intelligence people to see what is going on or to understand what was going on, but they also use it for dashboarding, for building reports, and for sharing those insights with other people. This is a screenshot of the platform. What I'll do later after presenting you the different use cases that I prepared, I will present the use cases in an interactive way. So you will see here an actual view on the platform. It's using a shared link. So that's why I can just click on it and navigate to it. But typically, if you use the platform, you would log in and you would access your projects, your data. So what are we looking at? Here you see the map. On the map, you see a density visualization of vessel activity. This is a very old data set. It's a data set that we put in the platform from our first customer, from Spire, as a demonstration of what is possible. We all know that this region is very active these days and very common, and we do have customers that are using our platform to monitor and analyze the situation in the Strait of Hormuz. But keep in mind, this is an old data set. Just to give you an idea of this, of the interactivity of the platform, we built a big data architecture that allows our users to really work with this data at any scale. This is about 1.5 billion location records, so that's like 9 zeros. And we build a technology that allows users, for instance, to inspect what is going on through a certain area by just simply applying a filter. What you will also see is, if I go back to a smaller screen here, you will see that it's very similar to a geospatial or a GIS solution. It's multi-layered. So it means that you can work with multiple layers of data. You can choose the styling of the data. You can filter on the data. So for instance, if I want to see only the cargo traffic, I can apply a filter and it immediately filters out all the noise in the map, and I'm just looking at the cargo traffic. What you will also see is that everything is very interactive. So whenever I zoom in on an area, you will see that the map will update, but also the timeline here that shows me the number of ships that we're looking at. And also the statistics here on those ships are updated very interactively. So this is what I will be doing with the different use cases today. If you want to have a more in-depth demo of these capabilities, just let us know and we can schedule maybe a more customized demo at some point. So that brings me to the first poll. And the poll is I want your input because we have such a diverse audience. I want to see which use cases you would like to see. I will probably select three of them that get the most votes. So please indicate what you would like to see um, and submit your answers. So I'll wait a few more seconds so that everyone can cast their votes. You can choose multiple options. I'll just take the top three chosen. And if you're unlucky and your vote is not there, we can still schedule. Okay, I see real-time vessel monitoring is one that is quite high up. It's first in my list, so I will do that first. And then I see port intelligence and data QA are also there at the same level, and then dark vessel detection. So let me try to squeeze those four in without making it too quick to follow. So the first one is real-time vessel monitoring. That one is actually interesting because it's both real-time, but there's also sort of an historical aspect to it. So let me click on the link to jump to the platform. So what you will be seeing here while it's connecting, this is an AIS feed that is freely available. So this is an open source AIS feed. And what we did is we're using the API, the XYZT API, to every 5 minutes or so, I believe, to take all those AIS messages and push them to the XYZT platform. So that's what you see in this layer called real-time AIS v6 in the meantime. So those are all those little dots that you see. They're actually ship locations with a certain state, certain heading, and so on. What you will also see is that there's a little trace behind them. Then that is because I put a filter here on the last hour. You see it's always locked to the last hour of data. I can change that. So I can, instead of looking just at the last position, even if it's real-time data, I can still navigate back through time, and I can sort of do a short replay if I want of what is going on. So I can, even if I'm looking at real-time data and something happens, I can go back very quickly and see what is going on. So in this case, it's both real-time and accumulated historical data. You see the visualization is a little bit different from what I've shown before. This is because in this case we use line-based visualization. So we connect the dots basically, and it gives you a better sense of individual vessel movement. So this is a typical visualization that our customers would use when they really want to analyze how traffic flows. All of this is very customizable. So for instance, I'm using a dot, but if the ships have dimensions, I can switch to a different view and look at how the ships are oriented. For instance, here in this anchorage zone, you see the ships follow the direction of the current. Styling, filtering is all there. So also here, for instance, I could apply a filter to this anchorage zone and only see what is happening inside. I could build up dashboards. I could build up monitoring to, for instance, show me always the number of vessels in the different anchorage zones on different dashboards and so on. So this you can do with your own data. It doesn't have to be AIS data. We do have customers that also work with, for instance, radar data. So it can be anything that that has a position and a timestamp. That's basically the main requirement for getting this type of data in. So that's the first, and I'll move to port intelligence, which was the second high up in the list. So I'll skip through these slides. I can give them later on as well, in a custom demo or a custom session if needed. So port intelligence, I have different demos. I'm going to show you a couple of them. We're used in many projects for ports, and this screenshot that you see is one with Port of Antwerp Rouge, where AI was being used to detect anomalies in data. So AI was being used to detect suspicious behavior or abnormal behavior in a port. And then XYZT was used as sort of a reporting mechanism to visualize those results. And so here, for instance, you see a tanker movement that was a bit weird in the port, and the AI flagged it as being abnormal. So you see the movement going on from this side of the dock to the other side. Um, so this is one example where XYZT is being used by, and in this case it's with AIS and radar data, where algorithms run and dashboards are used to show the results. We had a continuation on this project with a company called Ineos. You probably know them quite well, where real-time alerting and real-time monitoring was done in the neighborhood of their jetty. So you see here on this map, there's like a jetty here that is used to offload all the materials used for the site, for the chemical site. But you also see here, and let me maybe jump to the interactive map. You also see here that there's a very large container terminal very close by the jetty. So here's this jetty. So, and this is an actual sized ship. So you would see that it moves in. And you see the color coding is also green. So it means that the ship has been flagged by the AI as doing a normal maneuver. But in this project, they also, of course, are interested in detecting abnormal behavior and alert that you through a dashboard. So you see, in this case, it's all normal. In the case of an abnormal situation, it would move to an abnormal situation, and that is happening actually in this screen. I can open that as well. Let me close these ones. So here you see a case that was reconstructed from a historical case. It's a little bit different from what at some point almost happened. But you see from this point on, at this location, the algorithm, the AI algorithm flagged the ship as anomalous. And at this point, there was a warning raised, and operators, for instance, could still close the valves of the jetty in time. Of course, this is simulated and it's not a real case, but this is what they are afraid of because it's such a busy area, and sometimes with the wind and yeah, all the operations going on here, there's this risk of collisions or allisions. Another example I want to show that many of our customers use is where they use vessel tracking data to analyze not only congestion or the performance of the throughput or the wait times, but also to analyze, for instance, how vessels maneuver in very tight areas. So you see here what I did is I put a filter on only the larger vessels, so above 100 meter in length. And I'm just plotting over a month time, I'm plotting a density map of how vessels are moving. And for instance, if you have incidents or you're concerned about what's happening in certain areas, you can apply filters like this and only see what is happening for the vessels coming to this area. And by plotting all the individual traces of the icons, which I'm doing here by enabling this, you get to see how the vessels basically move in and out of those different regions in the port. And so you can see how they turn, and you can even see the density of those maneuvers. So you get to see how when they move in and out, how they would turn in those areas. And this type of information is also used by port authorities and analysts to see, okay, how is traffic moving in the port? And because vessels get bigger and bigger, this is a real risk and a real something that people want to look into. There's many more applications in port intelligence. There's so many statistics, analytics, monitoring, alerting that you can do. Um, but I'll skip to the next one. Data quality analysis is actually an interesting one. It's a little bit of a different use case than all the other ones because this is closer to the people that generate data or collect data and then maybe sell the data to other people or integrate data into their own solutions. This is actually one of the use cases that Spire Maritime also started using us initially. And it's really two things. First of all, it's, for instance, looking at coverage. Where do we have data? And I'm going to take the same open source example that I used before with data from that free open source AIS hub. And just by plotting those dots on the map, you get to see what their coverage is. And you see it's actually not so good. It's very diverse in areas. Of course, it's in some areas quite good because there's an AIS receiver there. So for instance, here you see in the North Sea what the coverage is. And we have users using this type of analytics where they analyze in very detail for different zones, for different areas. What are the number of messages that are coming in? What are the number of vessels that we see? And then they decide maybe to procure different data providers for different areas to augment their whole offering. A typical analysis that is done when you look at data is not only coverage, but it's also about looking at the gaps in the data. As you know, the ships, they don't send a message every second or millisecond. And sometimes they send it only every so many minutes. But also you have gaps, of course, because you don't have coverage. And then you want to analyze, okay, what's the distribution of the gaps in a certain area. And so with that, with our platform, you can also analyze those types of things. Here we also even visualize the connections between the last seen message and the next message, color-coded by the duration in between, which allows analysts to go in and see how their data quality is different in different regions. Here's an example. I quickly show it because I still have a minute. Oh, I don't have it online. Precies. I probably used the wrong link there. So I'll show it here on the map. We also have users that already aggregate those types of statistics over time in cells. So in hex cells, for instance, and then they use this data in our platform to further analyze where are the bigger gaps, where is the poor data, where is the good data, and so on. And that brings me to dark vessel detection. It's a good example of how the platform can handle multiple types of data and join them in space and in time. And in this example, we're going to use Sentinel SAR data. It's actually a demonstration that we also at some point did in another webinar, I believe. So in this example, what you see on the left, you see AIS traces. So you see locations of vessels. It's actually like before, there's a whole history behind it. So there's the whole trace behind every vessel. And the time instance here on the right, it's a SAR image, which is a synthetic aperture radar image from space, from Copernicus. And that captures like reflection in this case. And by the way that you see certain reflections, you know that something is there or not. And it's particularly good to detect vessels. And so we have projects where customers use this data to detect, for instance, where there's activity that is not seen in AIS. So for instance, here you have those couple vessels here on the left in AIS. You can see here that they're also detected by the SAR image, but you also see, for instance, here on this location, which is somewhere here, there's no vessel like that. And of course, you can combine those on top of each other if you want, or you can do those type of things side by side. And so we have customers running jobs that ingest this type of data continuously. Whenever there's a new image for the area, they ingest the data, they ingest the AIS data, and they can qualify what is going on. So that brings me to the last use case. And before going into the next discussion on how to do this on your own infrastructure, we have another poll. And the poll question is, if you're already working with AIS, what is hardest for your team? Yeah, working with AIS or maritime data in general. First option A, the amount of data. B, combining the data with different sources of data, maybe even your own databases. C, understanding change, how things move. D, detecting anomalies, looking at risk, compliance issues. And then finally, E, turning what you do, what you analyze into dashboards and operational decisions. Again, you can choose multiple. So I'll leave it a minute here so everyone can answer. All right, let me check. Okay, here we go. All right, so I think the top issue is detecting anomalies, risk, or compliance issues. So this really, I believe this means that people want more automation, want more automatic handling of the data. And that's, of course, where the whole agentic AI can help a lot in this process. Good thing is the platform can be used with agents, can be used with MCP servers, for instance. So you could connect up your AI. The next part, and it's only a very short part I wanted to talk about, is so that you know that you can do this with your own data, but you can also do it on your own infrastructure. And at the time when we started XYZT.ai, we built an entirely new data structure, an entirely new way of handling big data. But as a startup, we were also very constrained by the cost in the cloud. And we didn't have basically the opportunity to spend a lot of dollars on compute and storage. So what we did is we made something that is very, very optimized, very compact in both storage and processing, which means that it runs basically on any architecture. It runs on your local machine, it runs on a very small machine, even with big data sets. And last year, I was invited to give a presentation at the NATO event where I was talking about doing this in a very secure way on the tactical edge. So, for instance, imagine on a battleship, you want to have this type of capability, how to do that. These are a few slides from that presentation. And I made a comparison between the cloud capabilities at the time and the hardware capabilities now, and showed how you can do everything locally on your own machines these days. Of course, in the cloud, you could always go bigger and more scaling up. But even on a small laptop like mine here, which has like only 32 gigabytes, you could go in and run everything that I've shown today. You could just run it on your own machine. So this, for instance, is a demo. I just quickly prepared it with the same type of data, and it's just running here on my local machine. So there's no clouds involved in these types of things. And you see it's working on the same exact way how it's working in the cloud. Sometimes it's even faster because you don't have the network latency that you would see when you connect in the cloud. So that having said, basically we have two versions. In essence, it's the same because we deploy in our cloud that we manage, we deploy the same version that we license on-prem. So we have XYZT.ai SaaS, it's software as a service. We manage everything, we host everything. And then we have XYZT.ai on-premises. There we basically deliver a software package. We deliver normally a Docker, and inside there's the platform, and you can deploy it as a monolith. You can deploy it in Kubernetes if you want. You can deploy it on Azure, on AWS, whatever you like. yourself. So that's xyzt.ai on premises. So I think that takes me through the half hour that I had. Um, I didn't show all the demos. I went a little bit quick here and there. So if you're still interested to see some of the other demos or you want something more customized to your requirements, your use case, let us know. Um, let us know here whether we can contact you, and we will reach out and listen to your use cases and requirements. Okay, thanks for answering that. And with that, I will go to the takeaways. So I just wanted to make sure that you know that there's more than just vessel tracking apps. There's more that you can do with technology already. You don't have to build those things yourself. We spent many, many years on optimizing and extending all those capabilities. And it will allow you to move beyond real-time tracking. Important for us is that it should work on any data. So it should work on AIS data that you bring yourself, but it can also work on radar data, on maybe some satellite detected data, some gridded data, your own background layers, whatever you want to connect to. And finally, getting increasingly more important in the current geopolitical situation, deploy, of course, on your own infrastructure, securely air-gapped to the internet, for instance. So with that, I think I can take a few questions still. Um, Let me check whether something was asked in the Q&A or in the chat. So let me open that. Okay. Let me check. Okay, there was a question I think already asked beforehand um, about how accurate are ETAs. Like, I know in maritime, especially when you plan your operations or your trades, when a vessel arrives is important to know. And for that, people and organizations, they compute ETAs. So based on where a vessel is now and maybe some information about the destination, you want to basically forecast or estimate when vessels arrive. We don't do that ourselves, those types of predictions or computations. There's many companies doing that. So if you're interested, we can forward you to any of our partners that is doing that. How accurate they are, I leave it to them to answer that, because in any case, situations change when a vessel moves. We also know that some vessels are allocated really on demand. So things change all the time. And I also know that those organizations, they recompute those ETAs continuously. So um, let us know if you're still interested in finding out more. We can bring you in contact. Then let's see, is there another question? Yes, there's one more question that I see, but please put anything in the chat that you want. And the question is, how far does it scale to the amount of data? And that's an interesting question. Um, so there's different things to it. In the cloud, where we manage the infrastructure, we have to provision certain machines and certain amounts of memory and so on. And there, typically, our customers, we put them on a 1 billion record per data set. So the type of analysis that you've seen with 1 billion, so 1 to the power 10 to the power 9, so 9 zeros, number of records in one data set. And then we can still allow them to do interactive sub-second analysis. We have some customers that go to 1.5 billion, some go to 500 million. But that's roughly what we allow in the cloud. If you have your own deployment, you can, of course, go beyond that. The data structures are multi-scale, they're adaptive to that. In addition, we do have a capability, and I didn't show it today. It's called data stores, where you can basically put all the data that you have. There's no limit unless you're running out of storage. You just put everything there. We structure, we index all the data with the same algorithms that we use for the interactive analysis. And then you can extract the subsets of data very quickly. So for instance, imagine you have a 500 billion AIS data set, you put it in a data store, and then the users can go through the UI, they can select an area, they can select whether they want the traffic inside or through, they can select maybe only the fishing vessels, and maybe only the ones that were there on during the night, and then they can extract this data. It takes then a little processing job to extract the data. Normally, it runs in a few minutes. Sometimes it can be a couple hours, depending on the type of query. And then you get the data set, like in an interactive data set that I've shown, and you can just further analyze and review the data. So with that, if there are no more questions, I would like to thank you for joining. I hope this was sort of a good introduction to the philosophy of XYZT.ai. Of course, I couldn't show everything that I wanted to, but at least it gives you an idea. Reach out to us. We're very open to listen to your needs, your requirements, to partner and make the maritime industry more efficient and more safe. So thank you for joining, and see you next time.